Hello students, welcome back to this new session. Now let us continue with the new topic in the same module, that is module 2. We so far discussed about bilinear transformations. We also learned Cauchy's theorem, Cauchy's integral formula we derived, and also the generalized integral formula. After that we have to discuss some conformal transformations. Name a few. We have been given with in our syllabus w is equal to z square is one of the transformations that we need to discuss in detail. W is equal to e to power z we have to discuss, and also w is equal to z plus 1 by z. Okay, these are three conformal transformations that we'll be discussing in detail. So for now I'll start with the beginning for the first curve, first transformation, that is w is equal to z square. So let's see what happens here and how to take the image of what exactly here we will be doing is, given any curve or any kind of image in the z plane, how it will be transformed in w plane, that we will be seeing. For that, what we do is, we first put z is equal to, in this transformation only, we put z is equal to x plus iy, or z is equal to r into e to power I theta. Okay, either of the two, we as per the required condition or as per the required this, we will substitute z is equal to x plus iy or z is equal to r into e to power I theta. Mostly these substitutions, z is equal to r into e to power I theta, will be doing in the case of circles. Okay, and most of the time we'll be using z is equal to x plus iy. Just remember all this, and so that in this entire w we try to write it as u plus iv. So given the transformation w is equal to u plus iv, we try to separate u and v, that is we try to express u and v in terms of x and y and r and theta, or r and theta. Now let's continue with the discussion for w is equal to z square. So here is one problem. Find the image of the line x is equal to c. So as you see, x is equal to c will be a line parallel to y-axis, is it not, where c is constant under the transformation w is equal to z square. So let's see how the line x is equal to c of the z plane is being transformed in the w plane under this transformation. Let's see what happens to the line. Okay, so for this we will start our solution. See here, you have w is equal to z square, and given that x is a constant c. Okay, so first what I will do is, in this w is equal to z square, put z is equal to x plus iy. So you will get w is equal to x plus iy whole square, or it is x square minus y square plus 2ixy. Okay, now since your x is a constant c, let us substitute x as c. So it will be c square minus y square plus 2icy. Now let us separate your real and imaginary parts and see what is u and what is v. So your u is, actually w is u plus iv, right? So what is u? U is c square minus y square, and v is 2cy. Okay, now we can take the value of y from this equation. So what is y? This implies y is equal to v divided by 2c, right? Let us substitute it here. U is equal to c square minus v square divided by y square it is, so it will be v square divided by 4c square. Write it as 4c square here. Now take the LCM and try to rewrite the solution. So it will be u square, 4 into c square will be equal to 4c to the power 4 minus v square. The equation reduces to this form. Okay, or we can write this equation as v square is equal to, see, I can write this equation as v square is equal to 4c to the power 4 minus 4c square into u. Now I can take c square common, 4c square common. So you are left with c square minus u. C square minus u. Or further I can rewrite this as v square is equal to minus 4c square into u minus c square. So what is this? What is this? This represents the equation of a parabola. This represents a parabola which is symmetrical about the real axis. As you see, it is quadratic in v square, which is the imaginary square, right? So which is the imaginary axis, right? So since it is coming even powers in v, so it should be symmetric about the real axis. That's quite clear. Similarly, what about the vertex of the parabola? The vertex of the parabola is c square comma 0. If you put v is equal to 0, you get u is equal to c square. See that, look at that. So you get the vertex, it is passing through the real axis at this point, okay, and the focus is the origin. So let's draw. So therefore we can say that the constant x is equal to c, a line, this x is equal to c is a line in the z plane that has been transformed to a parabola of this shape. So let me draw and show you how is your line in the z plane and how is it being transformed to a parabola under that transformation. So say this is a z plane, x-axis, y-axis and the origin. We are having x is equal to c. Say if this is c over here, so x is equal to c will be a line parallel to y-axis. Say this is x is equal to c. Okay, let me draw a w plane now. So say this is w plane with the real axis and the imaginary axis and the origin. Here we are saying vertex at the point c square comma 0. So I can say this as c square comma 0. Let this be point because it's a real axis. Since your parabola is symmetrical about the real axis, so it should be like this, right? Right? Yes. So let's draw the parabola now, and the focus is the origin. So this is the parabola. V square is equal to minus 4c square into u square minus c square. Okay, this line under this transformation w is equal to z square is transformed to a parabola of this shape. Okay, I hope you all have understood everything what to do here. So the question may appear, show that the line x is equal to c, it's transformed to a parabola. So in that case you are going to work like this and show you, and show according to the, you have to even draw the figure and show how the line is been transformed to a parabola. Okay, so this completes the solution for this problem. Let's work for one more of this kind. Okay, there are so many, about 5 to 6 problems to do in w is equal to z square and also the last discussion. Okay, let's continue with one more question in the same this. Okay, let's continue with another problem. I'll just call this as example 2. See here, same as the previous one. Previously we found the image of the line x is equal to c, yes, of the z plane under the transformation w is equal to z square in the w plane. Okay, so now let us see how this line y is equal to c, and now this time I'm going to take a line parallel to x-axis. See, y is equal to c will be a line parallel to x-axis where c is constant, and let's find the image of this line under this transformation in the w plane. For that, once again I will substitute. So since it is y is equal to c here, please make a note. We are going to substitute y is equal to c here. So once again we have w is equal to z square and y is equal to c square. I'm going to put z is equal to x plus iy, the same thing whatever we have done so far. Now let us substitute the value of y here. So you get x square minus c square plus 2i xc. Here this time you are putting y is equal to c. Everything is as it is. So once again write your u. Since your w is u plus iv, so separate your real part from here. The real part is x square minus c square, and what is the imaginary part? V is equal to 2xc. So from here I can put x is equal to v divided by 2c, like how we did in the previous case. Substitute it here. It will be u is equal to v square divided by 4c square minus c square, you all will get. Okay, or this will be 4 this equation can be rewritten as 4c square into u is equal to v square minus 4 times c to the power 4. Okay, or I can once again rewrite this equation as v square is equal to 4c square u plus 4 times c to the power 4. Or I can rewrite this equation v square as, I can take 4c square common, u plus c square will be left inside. Okay, I hope these steps are clear to everyone. It's just a simple thing. Okay, now this is nothing but this is also representing a parabola only, right? It is also symmetric about the real axis. And what is the focus of this parabola? Can anyone tell me? You just put yes. What is the focus of this parabola? It is also the origin. Can you tell me the vertex now? Vertex? Yes, I can rewrite this equation v square is equal to 4c square into u minus of minus c square. So that becomes plus. So the vertex becomes what? Minus c square comma 0 is the vertex. And focus is 0 comma 0. So yes, this represents, right there, this represents a parabola symmetrical about which axis? Real axis only, right? About the real axis. Yes, that is u axis. It is symmetrical about u axis because it is v square here. And focus as the origin. And what is the vertex? Vertex is minus c square comma 0, right? Yes. We have found the vertex, we have found the focus, and we know where it is symmetrical about. So let's draw that. First let me draw the line. So we had a line, say this is z plane for me. This is x axis, y axis. Y is equal to c, we had the line, right? We were finding the image of y is equal to c under that transformation. So I'm going to draw y is equal to c line here. Say this is c over here. So y is equal to c, a line parallel to x axis. This is the line. Now in w plane, what is happening? This is u. I need a better one. 1 minute. Enough space here. So say this is the real axis u, imaginary axis v. So the point minus c square comma 0, say minus c square comes here, right? So this is the vertex for it. So minus c square comma 0 is this point. Okay, 1 minute. Minus c square comma 0. Okay, and your focus is the origin and it is symmetrical about the real axis. So it should be something like this. This is the parabola required. So this equation is nothing but v square is equal to 4c square into u minus of minus c square, or I can directly write u plus c square over here. Okay, so the line of the z plane y is equal to c is transformed to a parabola like this. Okay, so I hope this is clear. Okay, let us continue with one more of the discussion. Okay.